Hello everyone. Let us now discuss how can we solve this problem. Push dominoes. So we are given with n dominoes in a line and we place each domino vertically upright in the beginning. We simultaneously push some of the dominoes either to the left or to the right. After each second, each domino that is falling to the left pushes the adjacent domino on the left. Similarly, the dominoes falling to the right push their adjacent dominoes standing on the right. When a vertical domino has dominoes falling on it from both sides, it stays still due to the balance of the forces. For the purposes of this question, we will consider that a falling domino expends no additional force to a falling or already fallen domino. You are given a string dominoes representing the initial state. L means ith domino has been pushed to the left, R means pushed to the right, and dot means has not been pushed. Let us look at the constants. So they are very low. N is equal to no, they aren't very low. It is 1 if I. So let us go and solve this problem by using the second example. Right, it is a quite simple problem if I have to say this. Right, you have this left, right? This is left, so this will be falling to the left, and this is left already. Now you have this standing upright. I am seeing this standing upright. Why? Because I doesn't have anything falling to the left after this, right? So after this I doesn't have anything, just after that I doesn't have anything which is falling left. So I got this right. Now I got this right again, but I'm not gonna take this right again. Why? Because just make sure that you got a left here. Now you do this right again, you do this left again, but this domino which is at this point is at the exact where it was. I think it's clear for now, right? Why I didn't uh, pushed it to the right or left. Now I have this domino to the right. So to the right, and then this domino to the left, and then this will be falling to the right, and then this will be falling to the left. Now I have these two straight dominoes. Now if I write the string, it will be something like left, right, uh, left, left, or dot, right, right, dot, left, left, and then right, right, left, left, dot, dot. I think it's clear for you. Now I straightly go to the intuition and let us just mix it or just make this by a sub problem. Now let us see. I am saying that I have R. That means this domino is falling R right side. This domino is falling to the left. Now I have 5 in this. Just don't apply any mass here. Just take this domino and this domino simultaneously. This domino I am pushing to the right. This domino, just take a 2 pointer. Let me not name it something like anything, but just I am saying that in the algorithm we will be using 2 pointers. Now I am here. Just push it to the left. Now I am here and push it to the right and push it to the left. Now I am the both pointers are here. I don't push it anyway. So I'll stop my loop when I get my 2 pointers at the pointing at the same index. I think it's clear for you now. Now I have some problem sub problems again. Now I have a right previously and I have this right again. Now what I need to do, I will not leave these dominoes which are standing upright. So they are standing up, so I need to make it to the right. Now what I do is I store this previous R where I got this R. Now I got the R again. Then what I need to do? I will make all these dots to the right. I'm just doing this to the R. I am just converting it. Now I have this R and I have this L. Now what will my previous R become? Previous R will become here. It will be my previous R. Now I have this L. I said you again R and L what I need to do. So I am writing it here. If you got R dot 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 and dot 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 something like that and L, then use two pointers. That's it. Use two pointers. If you got R and then something like an R, that means I got this as a previous R, the index as previous R. So R, then I need to start from previous R, go to the current index, start iterating from from previous R to current index and change to R. That means changing the characters to R. The same question I am asking you, right? What if you have to the left, right? So when I am having something like to the left, I will do nothing but going after when I got something like left, then I will go from the left and change it to the left, right? So I think it's clear for you. Now what I am doing here is I am having a right here. I just can't go and make all those to the right. So I will do one thing. If previous R is not equal to, wait a second, I'll tell you what, equal to minus 1. Okay, if it is not equal to minus 1, what it means, that means I have an L here, uh, I have this L and then I have an R here. So at this point there will be two pointer approach. So that's what I'll write here. Use two pointer approach. Okay, that's it. Now I am having again is not equal to minus 1. What if it is equal to minus 1? Okay, if it is equal to minus 1, just take this L, and if it is equal to minus 1, that means I doesn't have any R here. That's what I wrote here. So if previous R is equal to minus 1, that means I doesn't get any R. So I'll just make all these uh, things to the left. Now the same thing again here. I have done everything, but previous R is not equal to minus 1. That means there is R, and this all stuff will be L, R, R, L, and then again R will be up to here. Will be calculating the result, but at this point will be missing out this, right? So when you got R at the end, you are missing something here. I took the two pointer approach. I took this when you got an R and you got an R again. So it's something like remove this, then you will understand, right? If you removed and you got this previous R again, that's what I wrote here. This is my previous R and it is still there, and I need to make all this fall to the right. That's what the whole intuition is. So at the last I am writing this here. If after iterating, if previous R is not equal to minus 1. Why previous R is not equal to minus 1? Why I am saying it? Now imagine all the string contains only else and and dots. So this is my string and the previous R is still minus 1. That means I doesn't have any R in the string. So if I didn't check this previous R, I simply make this all to fall to the right. So that's the condition why I am checking previous R is not equal to minus 1. Then what I need to do? Start from previous R, go to end, then change to R. That's it. I think it's quite clear for you. And it is a simple question, but these people are making it much harder. If you got RL, that means I got a previous R. This is previous R and this is L. Then use two pointers again. So if previous R, so this is the last condition. I think yes. If previous R is not is equal to -1, then use two pointer approach. So if you look at the code, here I have if C is equal to R. I am checking. If previous R is equal to -1, just change it. Previous R is equal to I. That means the current index will be I, right? Previous R will be I. That means I have previous R, something like previous R is -1. Now I got an R here at an index of 2. So my previous R will be 2, right? So that's what I wrote here. Now else previous R is already there. Now what I need to do? I just start from previous R plus 1. Why previous R plus 1? So imagine you got here, then why you have to change it this to R as you already have it, right? So instead start from here. That's what the code says. J is less than or equal to I, sorry, less than I, result of J plus plus. Sorry, I forgot to mention previous, sorry, result is equal to S. That's what we'll be writing at the end. Result of J plus plus is equal to R and previous R is equal to I. That's what I said here. Previous R will be this, will be changing to this as I got a new R, will become the previous R. Now else if C is equal to L, what I need to do at this point? Now previous R is equal to -1. If previous R is equal to -1, that means this will be the condition, right? Where it is. Yes, this is the condition. Previous R is equal to uh, uh, -1. So start from here at the 0th index and go to here and change everything to L. I am writing it here. If it is 0, right? Previous R is equal to -1, right? Then I will go from uh, J is equal to I minus 1 and J is greater than or equal to 0 and change to L. Now, if previous R is equal to -1, then I am doing this and I am saying this again, right? Only if S of or say it as result of J should be equal to dot. Now, if that means if it is not -1, there will be something like R, right? If it is R, then what will be the two pointer approach? It will be L and R, right? So L will be previous R plus 1 and R will be I minus 1. Then what we'll be doing is while L is less than R, that's what the two pointer approach will be. Result of L plus plus will be from right, so right, and then result of L and then R minus minus will be left. I think it's clear for you till now. So this is how the two pointer approach works. That's what I wrote here. Now the question is what the question is, what if I remove this result of J is equal to dot? Why I placed it over there? Now, if I remove it and submit it, but before even submitting it, let us see. Else, that means I didn't get -1. Let me check a problem. What it will be the problem? L and then something like here L. So what I am doing this is R and then R, like R and then R and then L. Let us be like this. Now, here previous R is -1. Previously R will be -1. Now, what I have here is I am just getting previous R is equal to -1. But if it is not equal to -1, I am just starting from where this previous R is there and R is equal to I minus 1. So previous R where I got is here I got at -1 and +1 will be 0. So from here till here, what I am doing? I'm just doing, let me say what I am doing here. Previous r is equal to -1. From here to here, I'm just changing to L. Now, previous r will be here and the L that I got here, right? So previous r is not equal to -1. Now what I am doing here? Previous r plus 1 will be L and r is equal to -1. Then L is less than r, L plus plus r minus 1 minus will be L and r. L, let us see clearly. L will be, here is my r, and this is the condition if previous r is not equal to -1. Previous r is not equal to -1. So what I am doing here? So here it will be left pointer, here it will be right pointer. If you see clearly, previous r plus 1 will be left pointer and r is equal to right pointer will be I minus 1. Left is less than or equal to r, result L plus plus will be r. L plus plus will be r, will be r, will be, here it will be L, here also it will be L, sorry, it will be r, and then here it will be changing till the end, and here it will be L till the start. So that's the problem with this. So that's why just stop when you get an R. So that's the problem with this. So stop when you get the R. So I made that mistake. That's why I'm saying this to you. So else I think it's clear for you the two pointer approach, and I think I mentioned this previous R is not equal to -1. Just start where the previous R is there and change it to R. And if you like this video, do share it to your friends and do subscribe to my channel, and I have given the code link in the description. Go and check it. Thank you.